Machine unlearning allows a trained model to forget specific training data. Unlearning Comparator is a visual analytics system that helps researchers systematically compare different unlearning methods. It guides the user through building multiple models, comparing their performance side by side, and simulating attacks to test privacy. In this video, we'll see how Unlearning Comparator makes it easy to evaluate how well a model has forgotten what it was trained on. Specifically, we assume a scenario using the ResNet 18 architecture, the CFAR 10 dataset, and the class Frog as our target class to forget. Our workflow consists of 4 stages: build, screen, contrast, and attack. First, at the build stage, the user selects a base model, an unlearning method, and configures hyperparameters. The model builder then generates unlearned models based on these settings. At the screen stage, users review the performance of various models. The system provides baseline models such as the original model and retrained model. Users then select 2 models they'd like to compare in detail, based on metrics from the 3 machine unlearning principles: accuracy, efficiency, and privacy. The contrast stage helps users compare models side by side. First, we compare the original model, Model A, with the retrained model, Model B. This comparison is crucial because the retrained model represents the ideal outcome of perfect unlearning. As we can see, embeddings for the Frog class in the original model form a tight cluster, but they scatter into other classes in the retrained model. Next, let's compare Model A, which is fine-tuning, and Model B, which is random labeling. First, in the class-wise accuracy chart, Model B shows lower accuracy for the forget class Frog and slightly higher accuracy for other classes, as indicated clearly by the bars and dotted line, which suggests effective forgetting. Looking at the prediction matrix, Model A tends to misclassify frogs primarily as visually similar animal classes such as cat, deer, or dog. In contrast, Model B predictions display a more irregular pattern, spread across diverse classes. We also observe cases where the prediction proportion is high despite low confidence. For instance, one cell has a prediction proportion of 0.458, but confidence of only 0.133, highlighting how large a mismatch can remain hidden if only proportions are considered. In the layer-wise similarity chart, we see that Model B mainly affects the final layer, indicating limited changes in deep features. On the other hand, Model A also updates earlier layers slightly, compared to Model B. For instance, Layer 4.0 similarity for the Frog class in Model B remains high, 0.92, while in Model A, this similarity drops notably to 0.463, suggesting deeper layer-level changes. Finally, the embedding space clearly illustrates these differences. Model B preserves a distinct cluster for Frog instances, meaning certain features remain recognizable despite the changed labels. Additionally, the Over-Forgotten mode in Model A reveals instances from retained classes that were originally classified correctly, but are now misclassified due to unlearning of the Forget class. Lastly, the attack simulation view allows users to simulate membership inference attacks to verify privacy. To specifically evaluate the privacy of the gradient ascent method, we change Model B to gradient ascent. In this view, the user attempts to infer whether each sample's output distribution originates from the retrained model or from the chosen unlearned model, Model B, based on a selected threshold. For example, when the threshold is set at 0.15, the attack classifies any instance with prediction entropy lower than 0.15 as originating from Model B's output. Inspecting these instances through the grid visualization below, we closely examine one specific sample. we find that Model B confidently misclassifies this forgotten frog image as a completely unrelated class such a ship with high confidence, unlike the more natural predictions made by the retrained model. This abnormal confidence in unrelated classes indicates that the unlearning method might have inadvertently left traces of the forgotten data, potentially exposing sensitive information and highlighting critical privacy risks.